So, hi everybody. Sorry for the little delay. Hope it's better now. So, yeah, it's my talk. So I will just start. Okay. So who am I? My name is Omer Frenkel. I'm a software engineer and team lead in Red Hat, and I'm also an ovirt-engine maintainer in the ovirt-engine project. What I'm going to talk about today is how we made Ovirt to become a multi-platform management capable, starting with x86 and PPC 64, and basically how we got Ovirt to be a multi-platform. I will go through a little background of what we did to make this happen, a little bit about the people that did this work, and a little bit about Ovirt for anyone who less familiar with it. I'll discuss the problems that we had to face, the solution that was accepted, what we did. I will show a little code and configuration, and then discuss a little what is still left to do. So, some background. Our goal was bringing multi-platform management capabilities to Ovirt, starting with x86 and PPC 64, and basically having Ovirt to be multi-platform capable. Why? Why now? So KVM on Power system was announced recently, and also there was another announcement of the Open Power Consortium by Google, IBM, NVIDIA, and some other big companies, so this becomes relevant now. Also, it was a good opportunity to have infrastructure, to have more platforms supporting Ovirt, just in case more platforms will support KVM in the future. So, something very important, everything I'm going to talk about today was contributed by developers from Eldorado, Brazil. Eldorado is a not-for-profit organization. They are located in Brazil and focused on technology development. And basically, these are community members that contributed this support. And it was a really nice work with them. And I want to talk about this just a little because it was a very interesting process with these guys. So these guys wanted this integration. They sent design to the Ovirt wiki. We maintainers and other community did some review to this design, some enhancements, and once this design was accepted, the development, the implementation phase started. And again, we over IRC to make it a short cycle because this guy is in Brazil, so it was a big time difference. And also over mails, we solved out all the issues. Our maintainers work really closely with these guys, helping them figure out all the issues that they had, making sure all the code is being reviewed in a timely manner, because we really wanted, and we actually succeeded, to make it part of the current 3.4 release for Ovirt. So this is a really great success for us. Okay, so a little bit about Ovirt. Anyone here already knows Ovirt? Okay, good. So I'll go through it quickly just to make sure everyone will know after that. Okay, so by definition, Ovirt is large-scale centralized management for server and desktop virtualization. What it means is that we have open source alternative for applications like vSphere and vCenter, and it allows managing virtual data centers. The focus is on KVM for best integration and performance, so we are using KVM. And there is a big focus on ease of use and ease of deployment for the users. So Ovirt is really easy to deploy and use as administrators to create your virtualized data centers and for users as well. So it looks okay. So you could use Ovirt for small environments like this, single data center, single host, running a couple of VMs. This is basically good for demo and testing because here you don't have some really important virtualization features like live migration. You can grow with Ovirt to multi-data center and multi-cluster environment. Basically, you can see here, I hope you can see here, Ovirt manages multiple data center. Each data center has multiple cluster, and each cluster has multiple hosts. So cluster is some kind of a migration domain, and within cluster, you can live migrate VMs from one host to another. I want to give you a really quick high-level architecture for Ovirt just because I'm going to talk about these components later. So I'm not going to go too deep to Ovirt. So we have the engine. This is a Java application, runs on JBoss. This is basically where all the logic relays and all the decisions are taken in our engine. If it's scheduling decisions and other decisions. And this is also the gateway. All user requests are sent to the engine, and engine process it and do something with it. The engine talks with the hosts that actually runs the VMs. In the host, we have agent. We call it VDSM. The agent has a couple of important responsibilities. So first, it does all the host level configuration, if it's storage or network. And of course, handles everything that related to the VMs on this specific host. We are using libvirt for all VM operations, if it's starting, stopping, and migrating. And we also have another package called mom that is responsible for scheduling and SLA services. And finally, of course, on the host, we have running guests or VMs, virtual machines. And the guest agent within is the package that's responsible for sending information from within the guest outside. If it's IP or applications that are installed, every information that we want to show up in the engine web admin. And also responsible for some commands on the guest inside, if it's, for example, single sign-on, that we really have to communicate with the OS inside the guest. Okay, so what was the idea? So if you remember before, I showed you there are multiple data centers and each data center has cluster. What we wanted to achieve is that we could have a cluster which is x86 as today, and also have clusters from other platforms like PPC 64 cluster, and in the future, if available, anything that supports KVM. So ARM is the question mark. And the goal, of course, was adding this support with minimal, as far as possible, minimal changes to the architecture inside the engine and to the UI to use the existing infrastructures and so on. So what is the problems that we had to deal with? First, Ovirt was designed and developed with a single platform in mind. We only had x86 supported for KVM, so this is what we developed for, and this is the only thing that we had in mind. What happens is that there is no platform specifications. For example, VM devices like network and display and disk, just the same as in the physical world, not all the configuration are supported on all platforms. So for example, in Ovirt, you can have disk interface, IDE, virt.io, virt.io SCSI, and we found that PPC 64 doesn't support IDE. So we had to do some filtering to block users from trying to use it on PPC because we know it will fail. More problems that we had, so many assumptions were made without taking a platform in mind. So for example, PCI addressing is different between x86 and PPC 64. So we had to deal with it in runtime. We had to change the code that does the addressing. And I will show that later. Also, some features are not supported in all platforms. For example, live migration is still not supported in PPC 64. So again, it's a feature we had to block according to the architecture. So the solution that was suggested and eventually we used was using the strategy design pattern. I have some diagram of it. Basically, the strategy design pattern, what it says that you have the interface of what is supported, what are the actions that are supported, and you can have different implementations. So implementation 1 and 2 will be implementation for x86 and implementation for PPC 64. What it allows us is a couple of important things. Is first, selecting the behavior at runtime. We don't need all kind of special ifs and cases in the code to select which code to run. It gathers the specific code altogether. It encapsulate x86 code in the x86 strategy and the PPC code in the PPC strategy. And it allows people that are entering the code to find the specific code very easily because it all encapsulated together. And very important is that it allows us easily to add more architectures in the future. Other stuff that we had to take in mind is we are defining architecture in the cluster level. So we could have in one data center different clusters platforms. So you could have, as I showed before, cluster for PPC and cluster for x86. The CPU type is reported by the host. It allows us very easily to decide if a host can run in the cluster or not. And also in Ovirt, we have two configuration packages that are we are using it as infrastructure for deciding if some feature is supported. So one thing we had to do is add the architecture awareness to the configuration. So one is the global configuration for features, and another package that we have, we call it OS Info. It allows us to manage capabilities in the guest OS level. So, for example, Windows has a set of devices that it can use, and Linux has a different set. So we are saving it all in one configuration. And what we had to do is to add architecture to this configuration as well, and I will show an example later. Okay, so what was done so far? We can divide it to three main phases. First was to identify and move the specific code to the strategy classes, then changing all the configuration and creating the new configuration for the new architectures that we just added, and finally some specific coding for the PPC 64. So we had to, as I said, add the architecture field to the cluster and also supported CPUs. We have the supported CPU list in Ovirt that we are supporting. And once we implemented the strategy design pattern, so we could move all the specific code to the right place and basically create some encapsulation for the x86 specific code. Configuration. So I will show, I think it's the next slide, I will show you how the OS info configuration looks like. And it gives us great flexibility because the guys that contributed the code didn't have to invent pretty much anything. They were using an existing infrastructure, so they would basically just add the new architecture and the new values for the guest OSs and configuration, and it was just working out of the box. Or it gives us flexibility in the UI for filtering. I will show that as well. So this OS info, how does it look like? So this is a snippet of one OS, and you can see that we added the PPC 64 OS, and we added this CPU architecture class within, and the value for this OS is PPC 64. So basically there is hierarchy. So all we had to do is add x86 to the base OS of the existing OS, and just add this one, and all new OSs that we are going to add, if it's RHEL 6 and so on, will inherit from this OS. So basically it will be really easy to add more supported OSs once we verify they are working. Also, you can see that here we define the devices per OS. So for this specific OS, since it's PPC 64, the display protocols that are supported are only VNC, because SPICE is not supported on PPC 64. And this is how we use it in the code. So the OS info, just you ask for the package, give me what display types are supported for this OS in this compatibility version for the cluster, and it will understand from the OS what is the architecture and returns the list. I will show in the UI how it looks like as well. So specific code that had to be done. So first is the specific addressing that I talked before, because the addressing in the PCI addressing in PPC 64 is different than x86. I will show that. Also, we added the specific PPC 64 devices for VLAN and vSCSI, the SPAPR, or how you pronounce it. A lot of front-end adjustments, I will show you right after that, to filter out only the relevant choices for PPC. And we had, as I said before, to block unsupported features if it's snapshotting and migration. In VDSM, the host agent that I mentioned before, there was some changes in the topology. We added a processor name for the reported information, and also hardware information that had to be changed according to the new PPC. So how does it look like in the code? You can see that when this is the code before, when we were building VM drives. So there is no ask about the platform here. This is just, if it's virtualization, this is what you're going to do. There is no addressing code here, because on x86 we were relying on automatic addressing from libvirt, and in PPC 64 we had to be aware of the addressing. So is it clear? I hope it's not too small. You could see right under the case there is if let's say, okay, if there is no address, so let's create it, and basically you can see here we are getting the strategy by the VM. We are getting the strategy by the VM architecture. So this way the code is not aware of what architecture it's running right now, because we are getting the right strategy and then running the code. So basically running the assigned SCSI address code. So basically the code is not aware of the specific architecture because of the strategy. We also had a visitor design pattern, which has the specific implementation in the sub-project. It comes in handy. The strategy gives you the correct code for the architecture, and the visitor is responsible for actually executing the code for the specific command, if it's for addressing and so on. I will show you an example. So you can see here that we have assigned SCSI address and its architecture command, and we have implementation for run for x86 and implementation for run for PPC. And you can see that for x86 it's still empty because we are still relying on the old libvirt logic, and for PPC we have different addressing if it's a virtualization or if it's a SPAPR vSCSI. So the controller, the addressing on the controller is different. So what we have ready. You can create cluster and mention the architecture, VMs, templates and pools, everything that Ovirt has. Importing and exporting keeps the architecture information. Attaching disks according to the specific strategy, architecture, sorry. Searching, we can search VMs by the specific architecture, and managing VMs if it's starting, stopping, of course. So a little bit how it looks like. I hope you can see it okay. So this is the new cluster dialog, and you can see that below we added the new supported CPUs. So it's all a family of IBM Power, and basically once the user select the specific CPU, then the architecture is set from this CPU. So every CPU has architecture, so it's automatic. This is the new virtual machine dialog. So you could see that above the cluster is a PPC cluster. So the operation system is filtered out, and I can see only the supported. So currently we only have other OS, but once we have verified more VM OSs, this list will for sure grow. This is still the new virtual machine dialog. You can see, as I mentioned before, Spice is not supported on PPC. So again, this is filtered out in the UI, and this is really nice because it's pretty much magic. It's all the infrastructure of the OS info does this for us. So it was really easy and nice to do. Adding new disk for VM dialog. So again, you can see that the disk interfaces are filtered out according to the architecture. So we know that we are adding a disk to a VM which is a PPC VM. So we will filter out IDE because it doesn't work. What still need to be done? So there are still some issues booting from network on PPC VMs, and this the guys from Eldorado are checking this out. But more important, we have blocked features on PPC because they are still not implemented or not exactly working. So live migration is the most important one. Also, taking snapshots. VM snapshots is still not supported. And hot plug for disks is not supported. We do have hot plug for NICs, for network interfaces, but disks still no. Okay, so summing it up. Today, thanks to this work, the ovirt-engine is multi-platform ready. Today we have x86 and PPC 64 already in the 3.4 release, but it's very important to say that we now have the infrastructure to easily add more architecture really easily. So once we have KVM supported on more architecture, it will be, should be easy work to add it. There is a lot more information. So there is our website and the wiki that the guys from Eldorado created for the engine and for the VDSM, which are the big projects. And all the information and implementation is there. That's it. Yeah.
On the CPUs page where you listed the different CPU types, you have the different versions of the Power 7, for example, 2.0, 2.4.
Yeah.
What's the actual difference between them?
So basically, we have difference between a CPU because the virtualization features are different. KVM is different on these versions because you have different features that you could use. I don't know the IBM features by heart, but let's say that one CPU has some features that KVM can use and the other doesn't. So I have to specifically say what is the CPU type for this cluster because I want migration to work.
Absolutely, but how do I, as a user, identify which of the versions I am using?
So basically, you don't have to fill this out. If you leave it blank, the first host that you will add to the cluster will set this for you.
Okay, we'll set it up.
Yeah, we have automatic setting if you set it, if you leave it empty. Yeah.
About the thing which you said with the snapshots,
Yeah.
why isn't IBM snapshot supported? It should run on PP.
I think that there is some issue there with the storage. I don't know exactly what was the problem with Snapshot, but
But it was not just about disk unit, it was also about hot devices that they weren't working at all.
on PPC,
Yeah.
so maybe I'm not updated. I hope it's working as you say.
Because I'm always calling you because I like version just
Yeah.
Did you integrate that all in ovirt or did you integrate it in libvirt as well?
So
Or
they
what's
al
the
they also did
distinction
work.
between that?
So the work on KVM was announced regardless, and I think they did some work in libvirt, but mostly it was VDSM and the engine. So I think that libvirt does support it, but there are issues in VDSM.
So
Basically
it
for
works
snapshots.
better on ovirt than in libvirt itself.
Sorry?
It works better in ovirt than in libvirt.
I
When I
hope.
just use plain libvirt with the shell for that, with the virtualization.
So that's good news.
No, I ask you if that's the case. I don't know.
It should, yeah, it should work. We are using libvirt, the same as using Virsh, so VDSM is using libvirt as well. Okay?
Okay, so it's in libvirt.
Yeah.
Okay, that's good. And then another question, you said ARM.
Yeah.
You know, I'm quite horny on the and I can't wait till March because I'm dead set about the new ARM Opterons. Do you know of any work in that?
I have no idea. I'm sorry.
But you don't know if they work on KVM.
I don't
port
think
for ARM?
there is work on KVM for ARM. I don't think so, but I didn't look
You
for
didn't.
it.
Okay.
Yes. Sorry again.
Are there any plans to interact with the agencies or the algorithms? Because you're talking about Linux already running on the machine at that point.
Okay.
So the question was actually, at this point, what you're displaying, or what I understood from your display, is that you already have Linux running on the machine, and then you can build other Linuxes on top of that.
Yeah.
That would mean that the LPAR had to already be defined. Is there any plans?
What would be defined? Sorry.
The LPAR, the logical partition on the machine itself.
Okay.
So is there any plan to interact with the HMC so you can do configuration of the LPAR or do dynamic LPARs on it?
Actually, I don't know. I don't really know about this. I'm sorry. On IBM Power, so. Yeah, I think it's below because we are using KVM, and KVM is user space. So I don't think it has any interact in that. Okay, we're out of time. Thank you very much.